Imagine gazing at the night sky and witnessing one of the most recognizable constellations, Orion. Your eyes find the familiar outline, the belt, the sword, and then they move to the shoulder. But something is different. Something is brighter, unsettlingly brighter. The shoulder, or Betelgeuse as it's known to astronomers, a red supergiant star, is glowing with an intensity you've never seen before. What could possibly be the reason for this? Is the universe sending us a coded message? Or are we witnessing the prelude to a stellar spectacle that Earth hasn't seen in over 400 years? Welcome, viewers. Prepare for an astounding cosmic mystery that has even the most seasoned astronomers puzzled. Picture this. Betelgeuse, a star known for its spectacular red brilliance, suddenly flares up, exhibiting an inexplicable 125% increase in brightness, an event so unusual and unpredictable that it caught the attention of the world's most powerful space observatory, the James Webb Space Telescope. Betelgeuse, once a mere point of light in our night sky and part of the constellation Orion, has always fascinated stargazers. But with this unprecedented flare-up, its luster has become impossible to ignore. What could cause such a dramatic change in a star thousands of light years away? Could this be a prelude to the celestial event astronomers have been anticipating for years? Or is there an even deeper mystery waiting to unfold? Before we delve into this cosmic conundrum, let's rewind a bit. Betelgeuse is no ordinary star. It's a red supergiant, one of the most enormous and luminous stars in the observable universe. To give you a sense of scale, if Betelgeuse were in our solar system, its surface would extend past the asteroid belt, engulfing even Mars, with its diameter over 900 times that of our Sun. Betelgeuse's staggering size alone warrants our attention. More so, Betelgeuse is nearing the end of its life cycle. As a star exhausts its nuclear fuel, it undergoes dramatic changes. For supergiants like Betelgeuse, this often culminates in an extraordinary cosmic spectacle, a supernova. Astronomers predict that within the next 100,000 years, Betelgeuse will explode, outshining every other star in our sky. But could this recent surge in brightness be a sign that the finale is closer than we thought? To answer that, let's take a look at the tool that's been observing this cosmic spectacle up close, the James Webb Space Telescope, or JWST. Launched as a successor to the legendary Hubble Space Telescope, JWST is packed with cutting-edge technology, allowing us to gaze further into the universe, revealing cosmic wonders in unprecedented detail. It's this very piece of tech that alerted us to Betelgeuse's sudden glow-up. JWST's capabilities aren't limited to distant star observation. It can peer into the universe's farthest corners, detect light from the first galaxies that formed after the Big Bang, study the formation of stars and their planetary systems, and even analyze the atmospheres of exoplanets for signs of life. But amidst these grand tasks, its attention is currently trained on our enigmatic supergiant, Betelgeuse. Since the dramatic increase in Betelgeuse's brightness was detected, astronomers have been working tirelessly to decipher its cause. One plausible theory relates to the star's temperature. As a star's temperature fluctuates, so does its brightness. But could a temperature fluctuation account for a whopping 125% increase in brightness? That's where this cosmic mystery deepens. Another theory posits that the increased brightness could be due to a process known as a helium flash. This event occurs in certain types of stars where a sudden onset of nuclear fusion transforms helium into carbon, causing an intense release of energy and a subsequent rise in brightness. But again, the question arises, could such a flash be responsible for Betelgeuse's dramatic increase in luminosity? Each theory raises more questions than it answers, and with every tick of the cosmic clock, the intrigue surrounding Betelgeuse's luminosity continues to grow. But here's where we take a turn. While we grapple with the mysteries of Betelgeuse, let's consider another stellar enigma that has long puzzled astronomers, the case of Epsilon Aurigae. Another star in our galaxy, Epsilon Aurigae, presents an intriguing parallel. Every 27 years, the star dims for about 730 days, almost as if it's playing cosmic hide-and-seek. For decades, the nature of this disappearing act stumped astronomers. Could the unexplained phenomena of Epsilon Aurigae and Betelgeuse be two sides of the same cosmic coin? Both Betelgeuse and Epsilon Aurigae are supergiant stars, albeit behaving in dramatically opposing ways. One surges in brightness, becoming an unmissable cosmic beacon, while the other dims, slipping away into the cosmic shadows. But what if, in their stark contrast, lies the clue to solving these mysteries? To draw these parallels further, let's dive deeper into the mystery of Epsilon Aurigae. At the start of the 20th century, astronomers noticed its puzzling pattern of dimming every 27 years like clockwork. Epsilon Aurigae would lose nearly 50% of its brightness, remaining dim for about 2 years before gradually returning to its normal state. Countless theories have attempted to explain the star's peculiar behavior, from dust clouds obscuring the star to an orbiting binary companion. The most accepted theory today suggests that Epsilon Aurigae is a binary star system with a massive, cooler companion partially obscuring the primary star during their orbital period. So, can the mystery of Epsilon Aurigae illuminate our understanding of Betelgeuse's puzzling behavior? After all, both are supergiants, but their glaring differences in behavior can actually provide meaningful insights. While Epsilon Aurigae dims, possibly due to a cooler eclipsing companion, Betelgeuse brightens in a dazzling display of cosmic fireworks. Could this contrast hold the key to deciphering these stellar puzzles? Consider the theory of binary systems. What if Betelgeuse, like Epsilon Aurigae, is not a solitary star but part of a binary or even a multiple star system? Could an unknown companion star or an encircling disk of material account for Betelgeuse's surprising brightness? It's a tantalizing prospect that opens a whole new vista in our understanding of these enigmatic celestial objects. This theory, while speculative, is not entirely without merit. Observations have suggested that many, if not most, stars in our galaxy may be part of multiple star systems. Therefore, the possibility that Betelgeuse may have one or more stellar companions cannot be entirely dismissed. The tale of Betelgeuse and Epsilon Aurigae serves as a testament to the sheer diversity of stellar phenomena, from Epsilon Aurigae's cyclical dimming to Betelgeuse's extraordinary luminosity surge. These celestial events remind us of the cosmic mysteries waiting to be unraveled, mysteries that can reveal profound truths about our universe. As we grapple with the enigmas of Betelgeuse and Epsilon Aurigae, let's now shift our focus to another cosmic spectacle: the sudden and unexplained burst of radio signals known as fast radio bursts, or FRBs. Although they may seem unrelated, understanding these phenomena could offer indirect clues about the inner workings of our universe. Fast radio bursts are sudden, high-energy cosmic events that last just a few milliseconds. Since their discovery in 2007, FRBs have bewildered astronomers. The sheer power of these events, each emitting as much energy in a fraction of a second as the sun does in a day, raises countless questions about their origins. Some suggest FRBs could be the result of neutron stars colliding, while others speculate that they may come from highly magnetic neutron stars known as magnetars. There's even a more speculative theory that suggests they could be signals from advanced alien civilizations. As with the mysteries of Betelgeuse and Epsilon Aurigae, the enigma of fast radio bursts underscores the limitless wonders of the cosmos. Now, as we take this unprecedented journey into the cosmic depths, let's pivot our focus a bit and venture into another enigma that's been captivating scientists and stargazers alike. Have you ever gazed up at the night sky and seen a twinkling object moving slowly across the horizon? More than likely, you've spotted a satellite, one of the thousands that orbit our planet. But what if I told you that among these machines of human design, an alien satellite might be observing us? An object that defies our understanding of technology and space? Let's dive into the enigma of the Black Knight satellite. The Black Knight satellite is a term coined in the 1960s to refer to an object captured in photos taken during the Space Shuttle Endeavour's mission. The object, black and reportedly close to our planet, appeared unlike any satellite we had launched. Its origin and purpose remained a mystery. But just like Betelgeuse, could this be another cosmic puzzle waiting for us to solve? Could the existence of the Black Knight satellite be a testament to an advanced civilization keeping a silent vigil on us? Much like we observe distant celestial bodies, the speculation and theories surrounding the Black Knight satellite are vast. Some believe it to be over 13,000 years old, sent by a long-gone civilization from the Epsilon Buddhist star system. Others think it's a product of a Cold War-era secret space project. Or is it an intergalactic probe, bearing silent testimony to our every move? Just as the increased brightness of Betelgeuse is pushing us to question what we know about the stars, the Black Knight satellite is challenging our understanding of Earth's cosmic neighborhood. He sort of broke it down into achievable chunks, and we hope, as you said already, to see a test orbit or an orbital test launch in the coming weeks. Today was a really important part of that. My philosophy, for lack of a better word, is one of curiosity, where we want to expand the scope and scale of consciousness on Earth and beyond, ultimately to other star systems. In order to do that, we need to increase the number of conscious beings and advanced technology to the point where we can have a self-sustaining city on Mars. The goal is to populate the whole solar system and eventually go beyond our solar system to other star systems, which will require more humans. It's pretty simple. NASA's latest achievements serve as a testament to human ingenuity, inspiring Musk and SpaceX to reach even greater heights. However, they haven't completed one key aspect yet. They were going to put something in place but haven't done so. There's quite a lot of damage to the concrete surfaces around the launch pad, which they'll need to repair. They will have to address that issue considering the immense power generated. I calculated that it's about 70 meganewtons, equivalent to 100 Concorde airliners trying to take off simultaneously at Heathrow. That's a tremendous amount of power and heat, which can superheat any water in the concrete, causing it to explode outward. This appears to have happened today, so they'll need to make some adjustments. NASA will likely be pleased to see Musk making progress. They'll want to see at least 2 more flights by the end of the year, and they expect that he will achieve orbit. Evidence suggests that Mars most likely had liquid water at one point. Over time, as the solar system cooled, Earth was once much hotter too. Early Earth was molten rock, and almost nothing could survive. Even now, Earth is mostly molten rock beneath a thin crust, with hot, mushy rock below the surface. When it gets to low pressure, like at a volcanic eruption, the molten rock emerges as lava. As humanity stands on the cusp of interplanetary travel, Musk envisions a future where mankind ventures beyond Earth's bounds. What's mind-boggling is that the mass to orbit could increase by 50% this year, with SpaceX launching nearly 90% of all mass to orbit, not including Starship. Starship can carry around 100 tons to orbit per flight, with the potential to increase that capacity to 200 tons with full reusability. Last year, SpaceX launched around 1,200 tons to orbit, which is astounding. The rate of progress is astonishing, but these numbers will seem small in the future. To build a city on Mars, we'll need around 1 million tons to Earth orbit, which would translate to roughly 200,000 tons to Mars' surface, about 20% of whatever gets to Earth orbit. To make Mars self-sustaining, we will need at least 1 million tons to Mars' surface. Musk remains vigilant, mindful of the challenges that lie ahead in space exploration. At first, life support systems will be crucial, as Mars' atmosphere is only 1% as dense as Earth's and mostly carbon dioxide. Terraforming Mars by warming it up would evaporate frozen CO2, densify the atmosphere, and potentially make it more habitable, though Mars gets less solar energy than Earth. SpaceX has completed 193 Falcon 9 flights, aiming for up to 150 more this year. Musk reads a lot about history, observing that civilizations are not permanent. Many have risen and fallen. Life can't be just about solving problems. We need things that inspire us and move our hearts. Musk's quest to save humanity unfolds through the progress of SpaceX Starship, which has completed an impressive 193 flights. It's amazing how much has been achieved in just 8 years. Musk hopes that within 8 years, SpaceX will have sent people to Mars and the Moon. SpaceX's goal is to make life multiplanetary, extending life beyond Earth. This is important for many reasons, including the defensive aspect of ensuring the light of consciousness doesn't go out. Musk's vision is not just a possibility, but a probable outcome. We must take concrete actions to safeguard Earth and propel humanity toward inhabiting other planets. Time is of the essence to make Mars self-sustaining as quickly as possible. It's not just about getting people to Mars, but also about sending enough equipment to ensure that, if resupply from Earth stops, Mars can continue on its own. The rapid pace of rocket production highlights the commitment to advancing space technology at an unprecedented rate. SpaceX has Booster 9 and Ship 26 almost ready to go, with a steady cadence of rocket production and significant improvements between iterations. The key payload for these missions is information, which will allow for future improvements. Fairing recovery is also a notable achievement, demonstrating SpaceX's commitment to sustainability. They've now reflown fairings 300 times. The ambitious goal for 150 flights this year shows SpaceX's determination to push the boundaries of space exploration. In the long term, with full and rapid reusability, Starship's flights could cost less than an expendable Falcon one, possibly as low as a few $1,000,000 per flight, which boggles the mind. Combining this with orbital refueling, something SpaceX is well positioned to achieve, means a real path to becoming a multi-planetary civilization. This scenario mirrors the inspiring stories seen in good science fiction, but it's becoming a reality. As progress continues, SpaceX emerges as a beacon of hope, steering humanity toward a future where the cosmos becomes our collective frontier. This potential is inspiring, just like the moon landing in 1969, which was for all mankind. It is this kind of inspiration that makes life exciting. Although the path ahead is difficult, with many bumps, by the end of this journey, SpaceX will enable bases on the Moon and Mars, dramatically increasing humanity's presence in space. Ultimately, the goal is to ensure civilization's survival and security by becoming a multi-planetary species. The physics of Starship's design will allow for full and rapid reusability, making space travel much more affordable. This unprecedented capability will allow humanity to expand into space, perhaps even traveling to other star systems in the distant future.